Hello everyone, welcome back again to the online classes. This is your physics teacher. Hope you all are doing well. Today we are going to start chapter 1, physical quantities and measurement. What are physical quantities? You have learned about physical quantities in class 6. Physical quantities are the quantities which can be measured. For example, mass, length, time, temperature, volume, area, density, all these are physical quantities and can be measured. In this chapter, you will learn about the measurement of various physical quantities like measurement of volume and area of objects, measurement of density of regular and irregular shaped objects, and you will learn about speed. Out of mass, length, time, temperature, density, volume, and many more, mass, length, and time are fundamental quantities as you have learned in 6th class, and the remaining ones are the derived quantities like area and volume are the derived quantities because these can be derived from the fundamental quantities. Then area and volume we use to measure in our everyday life. For example, if we want to paint a house, then we should have an idea about the area of the house to be painted or about the area of the walls and the ceilings of the house so that we can bring the required amount of paint for painting the house. Similarly, if we observe the packaged items that we buy from the market like the milk packets or the beverages bottles, then we can find the quantity of the liquid mentioned on the packets or the bottles. So this quantity of liquid which is mentioned on the packets or bottle represents the volume of the substance present in that packets or in the bottles. So we need to measure area and volume very often in our everyday lives. Now you will learn about the measurement of volume. Firstly, what is volume? Volume is defined as the amount of space that an object occupies, or we can say that it is the three-dimensional space occupied by an object. For example, if we are having any substance like this sharpener, then what is the volume of this sharpener? It is the amount of space covered by it, or it is the three-dimensional space, that means amount of length, breadth and height covered by the sharpener is known as its volume. Now all the matter occupies space. We know matter has mass and it occupies space, so it also has volume. Solids, liquids and gases, each of these has volume. What are the SI units of volume? The SI unit of volume is cubic meter and it is also known as meter cube. Another units are cubic centimeter and the standard units are liter, milliliter, gallon and pint. Gallon and pint are the units which are used in the US countries. Now how we can measure the volume of various substances? We can have the regular shaped objects and the irregular shaped objects. So the volume of simple and regular shaped objects can be calculated by using arithmetic formulae. What are the regular shaped objects like cubes, cylinder, spheres? The volume of these objects can be easily calculated using arithmetic formulae, but the volume of irregular solids is determined by using indirect methods, and one of them is known as displacement method. So we will learn about that method in detail further. So before this, let us have an idea about the concept of unit volume. So what is the concept of unit volume? For this we can consider a cube or a cubical object. For example, dice. A dice is a cubical object with each side measuring 1 meter. So what will be the volume of that cube or cubical object? The volume will be length multiplied by breadth multiplied by height. So the volume of the given cube or cubical object will be equal to 1 meter multiplied by 1 meter multiplied by 1 meter, that is equal to 1 cubic meter. or we can say that the volume is equal to 1 meter cube. And if we are considering the smaller unit like centimeter, then the volume of that cube having each side 1 centimeter will be equal to 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter, that is equal to 1 cubic centimeter. So volume will be equal to 1 centimeter cube. And so we can say that the volume of a cube with sides measuring 1 unit will be 1 cubic units, as we have seen. If the sides, each side is of 1 unit, 1 unit means that can be either 1 meter or 1 centimeter, then the volume will also be 1 cubic units, or that means 1 meter cube or 1 centimeter cube. So such a cube is said to have a unit volume, and this type of cube is also known as a unit cube. The cube which is having unit volume is known as a unit cube. So we can say this cube is unit cube because it has the each side equal to 1 unit and volume equal to 1 cubic units. Now here is a group of 4 unit cubes: 1 unit cube, 2nd unit cube, 3rd unit cube and 4th unit cube. What is the volume of the given shape if each cube has unit volume? Here we have a figure or a shape, and each cube has a unit volume which is constituting this figure. The length of the figure is 4 units, breadth is 3 units and the height is 2 units. Now how we can measure the volume of this given figure? We know that it is a cubical object, so we can find out the volume by multiplying its length, breadth and height. That will be equal to 4 multiplied by 3 multiplied by 2, that is equal to 24 units or 24 cubic units. There is an alternate method by which we can calculate the volume of this given object. We can just find out the volume of the top layer of cubes. These are the top layer of cubes. We can find the volume of the top layer of cubes, and then we can find out the bottom layer, the volume of the bottom layer of the cubes, and then we can add both the volume of the bottom layer and the volume of the top layer of cubes, okay? And then we can find out the volume of the given figure. So you can read this, and then there is a relation between units of volume. So what is the relation between different units of volume? First one is cubic meter and cubic centimeter. As we know, 1 meter cube is equal to 1 meter multiplied by 1 meter multiplied by 1 meter. 1 meter is equal to 100 centimeter. So it will be equal to 100 multiplied by 100 multiplied by 100 centimeter. That will be equal to 10 to the power 6 centimeter cube. So 1 meter cube is equal to 10 to the power 6 centimeter cube. Or we can find out the value of 1 centimeter cube. That will be equal to 1 over 10 to the power 6 meter cube. What is the relation between liter and milliliter? 1 liter is equal to 1000 milliliters. And relation between cubic meter and liter, we can find 1 milliliter is equal to 1 centimeter cube, and 1 liter is equal to 1000 ml. We know we can write centimeter cube in place of milliliter because 1 milliliter is equal to 1 centimeter cube. So 1 liter will be equal to 1000 centimeter cube. Since we know 1 centimeter cube is equal to 1 over 10 to the power 6 meter cube, and if we find the value of 1000 centimeter cube, then that will be equal to 1000 multiplied by 10 to the power 6 meter cube. That will be equal to 1 over 1000 meter cube. So we can write 1 liter because this 1000 centimeters cubes is equal to 1 liter. So it is equal to 1 liter. 1 liter is equal to 1 over 1000 meter cube, or it is equal to 0.001 meter cube. Or conversely, we can write that this 1 meter cube will be equal to 1000 liters. So this is the relationship between cubic meter and liter. Now, how we can find out the volume of the regular solids? As you have learned that we can find out the volume of these regular solids very easily by using some common formulas or by using some common arithmetic formulas. First one is cube. So cube is having each side same. That means if we assume it is of length same length L, breadth L and height L, then volume will be equal to length multiplied by breadth multiplied by height, that is same. So that will be equal to L cube. Similarly, the volume of cuboid will be equal to length multiplied by breadth multiplied by height. The volume of cylinder is equal to pi r square h, where pi is a constant and r is the radius of this cylinder and h is the height of this cylindrical body. Then the volume of this sphere can be found by using this formula, 4 by 3 pi r cube, where pi is a constant, 4 by 3 is also a constant quantity, and r is the radius of this sphere. The volume of cone is equal to 1 by 3 pi r square h, where r is the radius of the circular base of the cone and h is the height of the cone. Next, how we can find out the the volume of irregular solids. The volume of irregular solids can be found by using indirect methods, and one of them is the displacement method. So in this method, what is done? We just take a certain amount of water in a measuring jar, and then we will measure the volume of the water in the measuring jar. After that, we will completely dip a solid in it, and when we immerse a solid in water, then the solid displaces an equal amount of water equal to its own volume. Therefore, the volume of the solid and water displaced will be the same, and this method used to measure the volume of the irregular solids is known as displacement method. Here you can see this activity. For this is the same activity that I have explained here. For this we require a measuring jar, a stone, string and water. What we have to do, firstly, we will take the measuring jar, we will take some amount of water in the measuring jar, and we will take the initial reading of water, that means initial volume of water in the measuring jar. Then we will take a stone and we will tie it with a thread, and then we will dip the stone inside this measuring cylinder or measuring jar. We will see that the level of water increases when we have dipped the stone in the water. If the level has been increased, then we will take another reading, which is known as the final volume of water. Now the final volume of water will be more than the initial volume of water, because the level of water has raised when we have dipped the stone in this measuring beaker. The difference between the final and initial levels of water will give the volume of the stone, and it is equal to the volume of the water displaced by the stone. This will be equal to the volume of the stone, and this will be the same as the volume of the water displaced by the stone. So by subtracting, for example, this is 40 ml and this is 30 ml. By subtracting, we can get the volume of the stone. So in this way, we can measure the volume of the irregular shaped objects. So the conclusion is the volume of an irregular solid can be determined through the displacement method. So thank you to all of you.